Chapter 1D deals with what? Dimensions. Use of dimensions. So the first part, what we mean by the term dimensions. Dimensions are what? Yes. Dimensions are powers. Powers of what? Yes, powers of M, L, T. To which? Yes, first line. Dimensions are powers of L, M, T to represent a physical quantity. Physical quantity as an example. Speed, here it is written as velocity. Speed, physical quantity is equal to distance by time. Distance is length, time t. Now let us first understand. If at the same time length or distance covered is more, speed will come out to be more. Same time, 1 hour car journey, 1 hour bus journey, car covers more distance. So if distance covered is more, speed is more. If time taken is more, then we say it is very slow. Then speed is less. So it is directly proportional to length, inversely proportional to time. So L's power 1, T's power minus 1. What about mass? Does not depend on mass. Speed, when you write the formula for speed, distance and time, there is no issue of a mass. Mass is powerless when you decide for speed. This is one example. Example number 2, acceleration. Acceleration is equal to distance, displacement divided by time square. You can also write as rate of a change of velocity with time, velocity by time. The result is same. Distance is what? Length, time t square, L1, t minus 2, mass is not there. So, acceleration. So, dimensions 0 for speed, dimensions are 0 in mass, 1 in length, minus 1 in time. For acceleration, dimensions means powers, 0 in mass, 1 in length and minus 2 in time. Time with you is 3 minutes to write. 3 minutes to write. B part is what? Dimensional formula. Dimensional formula. Yes. Dimensional formula is what? Is an expression which tells us how a physical quantity depends on mass, length and time. Same example, physical quantity speed, how it depends on mass, length and time. So, dimensional formula of speed is, yes, m0, L1, t minus 1. Dimensional formula of acceleration is m0, L1, t minus 2. So, dimensions are 0 in mass, 1 in length, minus 1 in time. m0, L1, t power minus 1. This whole expression is dimensional formula. 2 minutes to write. C part is what? Equation. C part is dimensional equation. When you say equation, that means you will have to equate. You will have to write something equal to. F is equal to ma. It is an equation. In chemistry, something plus something is equal to something plus something. It's equal to. That is what equation is. So, when a physical quantity as an example is what? Speed, is equated, physical quantity speed is equated to dimensional formula. This is known as dimensional equation. That means on one side of the equal to, left side it is physical quantity. On the right side it is a formula. So, acceleration is equal to, dimensional formula of acceleration is equal to m0 L1 t minus 2. So, now this total is an equation. Takeaway is what? What is the outcome of? Dimensions are 0 in mass, 1 in length, minus 1 in time. Dimensional formula of speed is m0 L1 t minus 1. Dimensional equation is v is equal to m0 L1 t minus 1. 2 minutes to write. Last part, dimensional equation. Refer to the book. Page number 1 by 53 in the given book. Serial number, physical quantity, relationship, that means formula. Then dimensional formula, then units, that is SI units. As an example, first one, physical quantity, yes, area, relationship or formula, area is equal to length into breadth. How you write dimensional formula for the same? Length, L is power 1, breadth, L is power 1, so L is power 2. Mass is not there, time is not there. Units, yes, units, distance is meters, meter square. Kar lo complete, completed. Take one full page. I will write number of physical quantities, draw it like this. We will write number of physical quantities, draw it in the form of a table. Next physical quantity is what? Volume. Volume is equal to what? Formula, length, breadth, height. So L is power 1, breadth is also length, power 1, height is also 1, 1. So L cube. Mass is not there, time is not there. M0, L cube, T0. Length is what? Meter, meter cube. Third entry. Third entry is density. Yes. Yes. What you read in the school is mass, it's a ratio. Mass to volume. Mass is m is power 1. Volume is L cube. So what you get is m1 L minus 3 T0. Mass is what? Kg per meter cube. Meters power minus 3. Completed. 2 minutes. I will write next 3 physical quantities and you will write the dimensional formula for the same. Fourth entry, book 1 please. Specific gravity. It is also known as relative density. Fifth, speed. Sixth, linear momentum. Book band. 3 minutes. Specific gravity अगर नहीं पता, not an issue. You can try the other two. We can try this one first. Speed. Bolo. Yes, speed we have covered it today. Distance by time. Dimensional formula. Distance is what? Length. Time is t. So L1 t minus 1. Mass has no role to play. Mass is powerless. Dimensions. Units. Length meter. Time second. Meter per second. Linear momentum formula. Linear momentum is symbol is small p is equal to mass into velocity. This mass is m. Velocity is what? Length by time. So it is m1 L1 t minus 1. Dimensional formula of velocity is this. Yes, mass is kg. Distance is meters per second. Yes, now we refer to specific gravity. Anyone who can explain? Specific gravity is? Yes, density, to be more specific, density of the material. I will explain how. Divided by density of water. at 4 degrees C. Means we want to know a particular material is how many times denser than water. No doubt this is to be discussed as and when we come across chapter number 7, Archimedes principle and others. But density of material is how many times density of water, let us understand. 1 liter bottle, water, full Bisleri, its mass is how much? 1 liter water, mass is equal to what? 1 kg. 1 liter water weighs how much? 1 kg. So it is 1 kg per liter. Now you drain out the water and now fill it with iron nails, iron material. You will find now the same bottle, 1 liter bottle, weighs 6 kilogram because density of iron is approximately 6 kg per liter. It is how many times the density of water? 6 times. So it gives me an idea whether a material will float or sink. If you place iron ball on water, sinks. Why? Its density is more than that of water. Then ice cube floats because density of ice is less. How much? 0.9, 90%. Density of ice to the density of water is 0.9. Another question. Water, ice cube. Ice cube, when you place it in water, floats. Agreed? What percentage is in and what percentage is out? Anyone? All of you have seen cold drink, ice cubes. Regular hai? 20-80. 20 in, 20% up. Very close. You are very close to the practical value, numerical value. It is 10% out, 90% in. Because the relative density is 0.9. If the relative density for material is 0.8, 80% in, 20% out. If relative density for material is 0.7, then 70% in, 30% out. To be proved. As and when we come across the chapter, to be proved. But density of material by density of water. Density, mass over volume. Mass over volume. So dimensions are what? mm cancel, L cube cancel, m0, L0, T0. It is simply a ratio. प्रैक्टिकल लाइफ भी करते हो तुम कि नहीं तुम कहने तो वो तो डबल है मोटा है वो तो डबल है कहते नहीं तो बहुत ज़्यादा पतला तुम कहने तो अद्धा है यू आर टॉकिंग अबाउट व्हाट रिलेटिव यू वांट टू कन्वे समथिंग नोट कर लो 1 minute. Point number 7 is acceleration. Then acceleration due to gravity. Seven is acceleration. 8 is acceleration due to gravity. Then force. Try 3 minutes. देख ले बेटा, acceleration, yes, displacement of distance by time square, dimensions, for dimensional purpose it is same, yes, length times power, mass is not there, yes, meter, seconds power, acceleration due to gravity is same, no change. It is due to gravity or due to other reason, whatever that be, acceleration is rate of change of velocity with the time. Force, yes, relationship, mass into acceleration, yes, mass m1, acceleration l1 t minus 2, and SI unit mass, yes, I will write complete also, kg meter seconds power minus 2, this is known as, this whole thing is known as Newton. So SI unit for force is Newton. Ten, impulse. 11, pressure. 12, universal gravitational constant. Three minutes. How much you know about these things? लिख ला किसने? कोई गल नहीं. Impulse you have not heard of. You are getting it for the first time. Agreed or not? Impulse, let me explain what it is. No doubt we have to cover it in the given chapter. There are a number of physical quantities, 67 to be covered. If you understand all, that means you know +1 syllabus. That is why some idea. Impulse, you are moving in a car, you apply brakes, the vehicle stops. You take time to bring your velocity to 0. But you are moving and suddenly there is a truck and you collide. Again, your velocity is reduced from 60 to 0. But what is the change? Why do you call the second one as accident? Why do you call the second one as accident? Yes, the word used is immediate. That means time taken is very, very small. Impulse means jerk. Fine. So the formula for the same is force into time. To be discussed, but let us see. Application. Player 1, cricket player 1 catches like this. This is one option. The second is, the second player draws the hands like this. Which of the two is better, first or second? Why? The second player has taken more time, yes. So the chances of injury will be less. Second, success rate, chance that the person will catch is also more for the second case. In the first case, the ball may come, hit and bounce, and it may result in failure. But you draw your hand like this, so the chances of catch increase and injury decreases. To be discussed as and when we come across the article impulse. But here I can write force into time. Pressure is what? Force divided by area. Universal gravitational constant you have heard of. Force is equal to G m1 m2 by r square. G is equal to what? Force into r square over mass into mass. Using this expression, dimensional formula of force is known to you. This is what? Distance, square of distance. This is what? Mass. Use these expressions, 3 minutes with you. Write the dimensional formula and the units. 3 minutes. Yes, dimensional formula for force m1 L1 T minus 2 into time. So what you get is m1 L1 T minus 1. SI unit is what? Yes, impulse Newton into time, that is workable. Newton into second. So it is Newton second. This is workable. Or you write kg meter per second. That's also acceptable. Pressure is force by area. Force is what? M1 L1 T minus 2 by area. What you get is M1 L minus 1 T minus 2. Pressure, yes. Force, yes. Newton, area is meter square. Newton per meter square, also termed as Pascal. Okay? To be covered. G, force, yes. Force, dimensional formula for force, M1 L1 T minus 2 R square by mass square. Yes, what you get is below M's power, L's power 3, T's power. It is what? Force is Newton, distance is meter square, mass is Last three physical quantities I will write now. This was the entry number 12. 13, work. 14, energy. 15, moment of force. Try. Work is what? Relationship. Force into displacement. Distance लिख दूंगे, even then it is workable. Energy, same. Energy is also same as that of work. You write it potential energy, kinetic energy, whatever energy you write. Energy and work is same. But if you write kinetic energy, let me say 1 by 2 mv square. Moment of force is a force into distance. Magnitude, only magnitude. Now write dimensional formula for all. 2 minutes. 2 minutes. Help. Force m1 l1 t minus 2. Distance l. So what you got is m1 l2 t minus 2. Units, joule. Energy 1 by 2 mv square. M is mass, speed is length by time. m1 l2 t minus 2. Unit is again joule. Question is, why not to take into account 1 by 2? Anyone? Why not 1 by 2? और बोलो. Refer to theory question number 1 so that you know the reason. Notes question theory question number 1, same chapter. 1D question number 1. Dimensions are powers of mass, length, time. This numerical value 1 by 2 has nothing to do with how kinetic energy depends on mass or speed. That is why it is not to be taken into account. So such factors 2 by 3, 4 by 7, 1 by 2, not to be taken into account. Right? Reason. Force into distance. Force is what? m1 l1 t minus 2 into distance, again length. Dimensional formula is m1 l2 t minus 2. But force, perpendicular distance, we will discuss Newton meter. It is different from work. How? To be discussed in the given chapter.